move forward. So you've all seen the title of my talk. I'd like to thank Irina for the kind introduction and for the organizers for inviting me to give this talk. So rather than giving a technical talk, I chose to give kind of an overview of the research directions I'm engaged with, which I think include, major ones, which all were triggered by a single unifying goal. And I think all of them represent somewhat the directions that on one hand are important, on the other hand are underexplored. And that's why I thought it's worth kind of sketching them out. If I manage to, I'm afraid there's some problem with my keyboard. Let me see if what would happen if I don't, how bad would it be? I just wonder, for the sake of time, if I just show it from, not sure how to, wow, it seems my computer got a bit stuck. Let me, I'm sorry, just that my computer doesn't respond for some reason. Let me try quickly, rather than restarting, let me try and quickly connect from my iPad, and maybe it will work. I don't know what happened, just got stuck, sorry. Just a second. Okay, so I already gave, thanks everybody again, sorry for the delay, and I already gave the introduction. So basically I decided to give kind of an overview of my major research lines these days, which decomposes to multiple research lines, all triggered by a single goal, which may be phrased as multi-text comprehension. This is work with lots of collaborators. So the general motivation is indeed comprehending multi-text information, thinking of one of the most prominent use cases in NLP, where for almost every domain, every topic for which we'd like to get some knowledge, more than anecdotal information, but really knowledge, the information would reside in text and in many texts, typically, look at search results, product reviews, etc. And these are hard to grasp. And one kind of intriguing fact, in my opinion, is that if you consider how, in the most common scenario in which we consume multiple texts, namely the output of a search engine, the way we consume them, we consume the information in the search results hasn't changed actually since the inauguration of search engines about 40 years ago. We still have to skim through the flat search result list. So we really need some new mechanisms, and I would expect that in 5 years or maybe even less, we'll start interacting with the search results in a different way, and not just search results, but also any other kind of setting. So thinking of that perspective, how would we consume information into the future? That triggered 3 research lines. One is more on the applied, the first is more on the applied side, which tries to examine how we might consume information in interactive manner. And the stress here is on interactive. And the first step we've done is working on interactive summarization. Then the second 2 lines concern with representation, with information representations, some sense meaning representations. But we've taken a certain slant in that direction. So one line regards with how to decompose a text to some information or meaning units, and the other is how to address the multi-text perspective and match information across multiple texts. So these are the three lines which I'll just sketch quickly in this talk. So starting with interactive summarization. So we said, as we've already sketched, texts are hard to comprehend, and what we would really like to know is to identify the various pieces of information which might get repeated, and then eventually somehow consolidate them together back. So comprehending multiple texts is all about decomposition and consolidation. These are, in my mind, the two kind of key concepts here. And if we can do that, right, we supposedly, that's what summarization does, right? Abstractive summarization that we have these days, and users are supposed to be happy. But even if, and you know, the even if is kind of a big if here, even if summarization would have worked well, you know, would the user really be happy? And there is a catch here, because if we are interested in a topic, aiming to gain some knowledge, then typically just the summary won't be enough. And you would like to get some more information, but to get more information means we need to go back to the text. So suppose Google would augment its search result with a summary, and the summary tells us, yeah, it's interesting. We're still to square one, having to sift through the text again. What might be nicer is some interactive means. So instead of kind of having to go back tediously into the original text, something we can interact with and selectively would present information to us, that would be something much more desired. So we have started working on this notion of interactive summarization, and I'll just give a very quick kind of illustration. Let me do that. So I just share, I mean, I'm sharing the same screen, but I just move to the demo. So what we see here is a demo that we have developed. And the demo, this demo allows us to explore a set of texts. In this example, you can see a cluster taking actually from the DAC dataset of 25 documents about school safety. What the systems give us initially is some kind of initial summary where we can get a sense of what's going on. But once we're into summary, we might want to learn more, like we might want to learn more about security measures. Okay, so I'm marking it, it becomes a query, I can type it, and then I get some more information about security measures. I see here some additional stuff, metal detectors. I see actually that the system suggests me to ask about metal detectors as a suggested query. I can click on metal detectors and got additional information. Or I may just, think of some query of my own, like teacher intervention, and get some more information about that, okay? Without having to get back to the documents. So this gives us some sense of what it means to interact with the information. But in this case, the demo showed just extractive, so both the summary and its expansions were extractive, so we've seen complete sentences, but in a more ideal setting, we would like something that's more fine-grained. We're not necessarily interested in complete sentences. Maybe we want just substantial information. And this is what's illustrated in another demo back from 2017, an ELLIS demo, where we get a summary. In this case, the domain was tweets, so we have a cluster of over 100 tweets on Hurricane Sandy, and we get some initial summary. In this case, it's an abstractive summary, fusing information from multiple tweets. And we can see that, for instance, Hurricane is highlighted in red, and if I hover over it, I can see that it was also called Frankenstorm, actually through coreference resolution. So coreference information gave me more information about this hurricane, how it's termed. I understand it's a very massive hurricane. Here I can see more details in the summary sentence about preparing for the hurricane. And then I can see that like the Coast Guard prepares, let me just scroll a bit, the Coast Guard prepare, state officials prepare, etc. So I actually could just expand with some highlights representing the agent in this statement about preparations, and I got much more information. Again, saving the need to go to the original tweets, and even saving the need to display again full sentences, but just showing substantial information. So that's generally speaking our motivation, to enable people to interact with the information and explore its content. Okay, let me present again. Okay, so this was the first one, and this is the second one where we're aiming at substantial information. So one line of research, we're trying to develop such interactive summarization algorithms. A major issue that comes up is how can we evaluate interactive summarization? We all know that NLP people are often reluctant to work on interactive settings because they are hard to evaluate. They require interaction with actual live users, all this hassle. What we came up here in that paper, this is archive paper right now, with a view that suggests that actually we might view an interactive summary as a series of an expanding snapshots of the interaction. And then each snapshot can actually be evaluated with traditional static summarization approaches, specifically recall-based, like Rouge recall or pyramid, and then actually plot a recall curve, which shows how much information the summary succeeds to provide. And the area under the curve could serve as a way, as a measure, as a concrete figure number to compare systems. And here we can see some actual system experiments that we did with different systems, some upper and lower baseline, showing that actual interaction, user interaction indeed helps to create better summaries, and that those that may be tailored to the user needs. And this also points at some kind of, it reflects on something that Henrik was referring to yesterday in his talk, that human-computer synergy can help. Henrik exemplified it in setting up systems in different ways. Here, it's in the actual usage of the system where interaction can help. So this is one line I'd like to promote. There were some issues with evaluation. I won't get into that we've solved in a couple earlier papers that kind of prepare the ground to how can we solve the problem of interactive summary evaluation. And looking forward, you know, we can think of interactive summarization. People work on conversational QA. People may think this is not something people are really working on yet, but on information exploration dialogues, there's very little work in these directions. And I think that's the direction to go. So that's one line. Thinking of interacting with information application in general, but particularly when you want to interact with information in the fine grain, brings us back the needs to decompose and consolidate information. And indeed, this was our motivation to deal with information decomposition, which is basically what meaning representations or semantic representations are concerned with. And indeed, there has been a little bit of work in the summarization community on using things like AMR to decompose information across documents and then try to consolidate them again. But when we tried to follow these lines, we felt that something like AMR will not be a good vehicle for us. And we know, and that's kind of a general concern with AMR, semantic dependencies, this kind of formal semantic decomposition formalisms. They all rely on some pre-specified inventory of relations, concepts like semantic role labels, verb senses from prop bank, etc. And across formalisms, inventories differ, so it's not clear which one to choose. They require expert training, so if you would like to improve something of that sort, you know, forget it. We will never replicate an AMR annotation effort. And they're also not well understood by downstream tasks. That's why we chose to go for kind of an open or a natural language-based approach. And there has been OpenIE, but we find more attractive the framework of QSRL. QSRL suggests that instead of assigning roles like agent and the location or theme, a sentence like Obama was born in Hawaii could be decomposed by two questions, asking who was born, Obama, where was someone born, Hawaii, which basically reflect the fact that the answer to the who question is the agent, and the answer to the where question is the location. But what we came up with is that this can actually lead to a broader meaning representation or information representation, because if you look at these, if I would communicate to you these two question-answer parent and specify that the born event is the same born event, I communicated to you exactly the same information is in the original sentence, right? I mean, you would get the same information. And that's how we want to expand it to QA-SAM, what we call QA-SAM, where the goal is to take a text and decompose it to the full, desirably full, okay? We won't get to 100% coverage, but as full as possible set of question-answer pairs, kind of minimal question-answer pairs that capture the same information as in the original text. And just to illustrate, if we have a sentence like this, Ukrainian boats failed to intercept British oil tanker, then we can get these 4 QSRL questions concerned with the verbal predicates fail and intercept. But we may also want to expand that to nouns and adjectives and get additional questions like those at the bottom. And again, if you look at these 7 question-answer pairs, you get exactly the same information as you get from the original sentence. So in that sense, the set of QA pairs does represent the meaning of the sentence. To do that, we expand the question-answer approach to cover nominalizations, like you see here, proved and proof would get the same question-answer pairs. This was a Colling paper. We had an ELLIS paper that tries to capture the informational discourse relations, like here, like we see reason and result, causal, temporal relations, covering about 15 relations from PDTP that we found as indeed capturing information, not just reflecting discourse structure or discourse layout, but really assert some information. And we are currently ongoing work. We also try to capture the main predications or assertions involved with adjectives. You can see some example here, okay? So once represented each text as a set of question-answer pairs, the next step would be how can we map across text? And mapping across text, we start approaching by linking these question-answers pairs. So one thing to link across pairs is traditional cross-document co-reference. We have worked on that in the recent year. We kind of contributed to state of the art. But more interestingly is how can we align not just elements like entity or event mentions, but the complete assertion, complete information units. And the idea here is to align or to do co-reference between these question-answer pairs. This might be one-to-one, like what was intercepted or what was attacked, the vessel, the boat, the tanker. It's the same kind of aligned information. And sometimes, I won't get into the details, but it may not just be one-to-one, but sometimes information captured by one question-answer pair is captured, the analogous information is captured in more detailed form by several question-answer pairs. So it's kind of a many-to-many alignment problem related to the question of predicate argument alignment that was attacked in the literature. So this is the general idea. And once you do that, you can imagine this is like a graphical view of several texts consolidated. You could ask questions that correspond to pairs of questions. Here, each edge represents a question and each node represents the focus of an answer of the question or an answer. And you could think of doing something similar to more structured meaning representations. So the takeout from this question-answer semantics prospect is that it suggests a natural language-based information representation, which is semi-structures. On one hand, it's natural language elements. They are amenable to embeddings and deep learning algorithms. On the other hand, they do provide you some explicit decomposition, which allows you also to do some explicit operation. And we kind of regard it as a midway between formal representations and fully opaque deep learning representations that we all know are hard to work with. And we hope that these two directions together, decomposition and alignment, can provide generic infrastructure for general applications. I'm going to skip the last part, which just suggests that we have done also alignment across text. We are doing alignment across text also at proposition spell level, kind of a more coarse-grained, more, let's say, traditional and less sophisticated level, which can also be useful for summarization. And we did develop some suite that provide such alignments with reference summaries, etc. And can be used. I mean, you're welcome to approach me if you're interested. So to conclude, multi-text information is an important goal, can be approached by decomposing and linking cross-text information at various levels, fine-grained or coarse-grained. And on the other hand, on the applied side, pushing interactive NLP, allowing people to enjoy the synergy between human and then NLP technology at the actual usage stage, not just at the setup stage, I believe is a very important direction. Thank you.
Thank you, Ido. It was very, very interesting. Thank you for the talk. We're rather late, but at the same time, I think we should take at least one question. Other questions from the audience? I don't see questions right now. I wanted to ask you a question which is kind of semi-related to this representations of documents and connecting documents and building this entity graphs. So I think now we are at the stage that we know that these deep models are capable of doing some of the things rather well, right? And some of the things they're not capturing, and maybe some people would think they will potentially never capture, right? So does it affect what kind of semantic representations for you we should focus on, and what kind of parts of representations we can trust this model to implicitly embed? Because back when AMR, for example, was developed, maybe we haven't realized that we would be as accurate with non-structured models, pre-trained models.
So my perspective here is that when you want to approach complex semantic tasks, and often, I mean, for which also, I mean, they're too complex to acquire for them kind of sufficient, end-to-end training data. I mean, how would you acquire end-to-end training data for interactive exploration of tests, right? Mm-hmm. I think in such cases, we need more control, about our kind of the primitive actions or the primitive units you want to work with. That's why my sense is, I just don't see how I can get control, on which elements to show, which elements kind of overlap, which elements contradict, which one to assemble into a summary in response to, let's say, to an interactive summary interaction, where you have to be much more fine-grained than in static summary, where you just spit out something and okay, that's it. I think where you need more control, we would eventually need some explicit, let's say, handles or some explicit units to work with, which we can control. We know that on implicit opaque, on the implicit distributed representation of neural models, we cannot pinpoint and do concrete operations on individual elements of the representation because it's distributed, right? So I think we need some combination. And I don't know which representation would work eventually, but I think taking this midway where the elements you work with are still natural language. Yejin Choi also mentioned yesterday, right? She also chose to represent knowledge rather than in logical form in natural language statements. So what we do is has a similar flavor. I think let's work with language, but let's also decompose it and not just work with it end to end. That's the rationale.
Mm-hmm. Thank you. I think Bonnie has a question. Bonnie, if you think your question can get a short answer, then please go ahead. If you think it's a long question, maybe we should do this over chat or.
Well, what I'd like to say is, if you go back to early work on summarization, there was considerable interest in multi-text summarization. And some of the most effective multi-text summarization wasn't looking so much at the language question labels, which are close to semantic roles, but are looking at the kind of decomposition in the field. And I'm thinking now about multi-text summarization in medicine, where there's a natural decomposition of questions into things like diagnostics and therapeutics and ways of characterizing the interests that people might have. And I don't see any of that in the kind of presentation, which is as if no study had been done before of multi-text summarization. So it's a comment or a question. You could take it as you will. Thank you.
Thank you.
I guess we are aware of a lot of the literature, not sure about that particular one. But I think it also supports the issue that, you need to decompose the information. In your example, it was formal decomposition. We think that much of that can be captured also with kind of natural language-based decomposition, but, that's the short answer.
Thank you, Ido, for the short answer. I think you can take it offline to figure out what the work Bonnie was referring to. Okay, so thank you. Now the poster session starts. Sorry to students about this delay, and we will be back here at 1:40.